Hi, welcome to my video on dividing cubic radicals. Division of cubic radicals. The denominator of a fraction has to be rationalized. No radical in the denominator. Just like the square roots, we're not allowed to have a radical in the denominator. Simplify each. 1 over the cube root of 8 is 1 over the cube root of 8 is 2. Done. 1 over the cube root of 2 we have to rationalize. So we need a cube root and a cube root to balance it out. We have a 2. So to make it a perfect cube, we multiply it by 4 and 4. That gives us the cube root of 4 on the top, and the bottom becomes the cube root of 8. And that becomes the cube root of 4 over 2, or 1/2 cube root of 4. That's a 1 understood. Notice we need a perfect cube. So the perfect cube that has a 2 as a factor is 8. So I multiplied 4 times 2 to get 8. So I multiplied the numerator. The denominator has to be the same to keep it equivalent. And to do this one, I can have a 4 is not a perfect cube, so I got a cube root. I have a 4 to get the perfect cube. I need to multiply by 2, because 4 times 2 makes 8, so I need a 2 here. So that's the cube root of 2, because of 1 times that. And that's the cube root of 8. So that becomes the cube root of 2. The cube root of 8 is 2. And again, we can call it 1/2 cube root of 2. Because that's, or you can leave it as cube root of 2 over 2. And D, we had to simplify. Again, we need a cube root. 9 is not a perfect cube, so we have to rationalize. And 9 got 2 3's, so one more 3 will do it. That'll give me a 27. So note, I have the bottom is 9 times 3 is 27. And the top is 6 times the cube root of 3, because the 6 is here. Rationalize that. The cube root of 27 is a 3. And the 3's cancel. 3 into 6 goes 2, so I get 2 cube root 2. Again, I have a 9. The perfect cube, I got a 9, and as a factor is 27s. So I need to multiply by 3. Or a 9 has 2 3's. 3 times 3. So I need one more 3 to make it a perfect cube. Cube root of 3 times 3 times 3 is 3. And following that pattern, I have a cube root. So we multiply top and bottom by the cube root. This is not a perfect cube. There's one x here. Cubes, I need 3 of them, so I need 2 more x's. So x squared. Cube root of x squared over the cube root of x squared. So 1 times the cube root of x squared. There it is. The cube root of x times the cube root of x squared is the cube root of x cubed. And that gives me the cube root of x squared on top. The cube root of x cubed is just x. And I could have a 1 over, or leave it like that. Okay, hopefully you're beginning to see the pattern. Cube root. These are not perfect cubes, so I have to multiply cube root. I got 2 a's, and I need 1 more. I got 1 b, so I need 2 more. So this is a b cubed. So this gives me 1 times this expression is that. So cube root of a squared b times the cube root of a b squared is the cube root of a cubed b cubed. And that becomes the cube root of ab squared. Can't simplify it. So the cube root of a cubed is just a. The cube root of b cubed is just b. 3 divided by 3 is 1. 3 divided by 3. So notice I need the inside to rationalize. The inside, these powers have to be a 3 or a 6 or a 9 or etc. to remove the radical. And that brings us to the next one. I gotta have a cube. That's not a perfect cube. So I gotta do cube root. I got 4 x's. So I need no roots. So that means the next multiple of 3 is 6. So I need a 2x squared. What do I need a 2? Because that gives me the cube root of x to the 6th. 1 times cube root of x squared. There it is. The cube root of x to the 4th, cube root of x squared is x to the 6th. So notice I have more inside. So 4 divided by 3 is 1. I got 1 left over. So I need 2 more to combine with this to make it so that the denominator, so the cube root of x to the 6th, 6 divided by 3 is 2. And I have my denominator rationalized. I have to make it, the bottom, this one, has to be a multiple of 3. A multiple of 3. Again, let's see if that makes sense. The cube root again, there's not perfect. Notice this is 2. It's not a multiple of 3. 7 is not a multiple of 3. So I need an exponent of multiple of 3. So I got a 2. So I need 1 more x to make it x cubed. I have a 7. I need a multiple of 3. So I need a higher one is 9. So I need 2 more. So x, y squared on the top. When I multiply 1 by that, I get what I have there. Now the bottom, when I multiply, should have 2 plus 1 is 3. 7 plus 2 is 9. That's perfect. So the numerator is already okay. And the cube root of x cubed, 3 into 3 goes once. The cube root of y to the 9 is y3. So 3 divided by 3 is 1. 9 divided by 3 is 3. So I need, again, this is cubes, so these powers right here have to be multiples of 3 in order to divide out and have no variable in the bottom, no root. Practice. Okay, pause the video and see if you can work these 8 out. Here we go. 1 over the cube root of 27 is 1 over the cube root of 27, perfect cube is 3. And 15 can't be simplified. The cube root of 125, 125 is a perfect cube, so it's a 15. Sorry, 5. When I say 15, looking at cube root of 125 is 5. 15 divided by 5 is 3. Now, not a perfect cube. So 25 is 5 squared. So that means I need 1 more 5. So that 1 more 5 makes it. Let's do it right here. 1 times the cube root of 5. There it is. The cube root of 25 times 5 is the cube root of 125, or 5 cubed. So that's the cube root of 5 over 5. 25 again, repeat. 25 is 5 squared. I got 2 5s, I need 1 more. If I multiply these, I get 125. So the cube root of 125 is still 5 because I got 3 5s. So if you did this, that's 2 5s, that's another 5, so that's that. So that then would work out to here because the cube root of 5 cubed, 3 divided by 3 is 1. And I got a cube root. And it's not a perfect cube, so I have to do some work. There's 1 3. I need 2 mores. could say I needed 9 because 9 makes it 27. So that's 7 cube root 3 squared is 9. That's the cube root of 3 times, that's a 9 times 3. There could be 3 cubed, or it could be 27, whatever you want. So that's a 27, or cube root of 3 cubed is the 3. So that could become, you could do it that way. 7 cube root 9 over 3, or 7 over 3 cube root 9, same thing. And again, hopefully everything is going okay. I got a cube root, it's not a perfect cube. I need a cube root. I got 2 x's, I need one more. One more y, because then I'll have the cube root of x cubed. When I multiply, the top is the cube root of x, and that becomes the cube root of x on the top. The numerator, the cube root of x cubed, is 3 divided by 3 is 1. And I can go, that's understood to be a 1. I can go 1, I can go like that, either or. And cube root again, they're not perfect. It is a perfect cube, but not the 8. So I need a multiple of 3, so that's an 8. I need one more a to make it a 9. I don't need any more b's. So I just need the cube root of a, no b's. So multiply 1 times the cube root of a, cube root of a. The bottom denominator becomes the cube root of a 9b cubed. That's nothing there. That's just b. I don't need any more b's because they're already okay. The numerator is okay. So 9 divided by 3 is 3. 3 divided by 3 is 1. And there's the answer. And here we go. Cube root. 4 is not a perfect cube. So the smallest perfect cubed is 2. 2. Why do I say 2? Because 4 times 2 will give me the cube root of 8. That's 24 cube root 2. And 24 cube root 2. The cube root of 8 is 2. And 24 divided by 2 is 12. Cube root 2. Notice, you cannot cancel the 2 into the cube root. They're not the same. And one more. Hopefully everything is working out and you're getting a pattern. Cube root. So I got a 5 and a 14. They're not multiples of 3. So I need a higher one. So that's a 5. I need one more to make it a 6. And I need 2 more y's to make it a 6. So this is x, y squared. So we multiply x squared y cubed root, cube root of x, y squared. And your denominator, and I write it out, is cube root x to the 6th, y to the 6th, x squared y cubed, cube root of x, y squared. 6 divided by 3 is 2. 6 divided by 3 is 2. And these x squared cancel. And y cubed divided by y2 gives me, that cancels to give me a 1. So it's y cube root x, y squared. Good one to end off. And remember, again, underneath here, you need multiples of 3 in order to have the root to cancel out, get perfect cubes. And that's explaining a little bit on division. And if you like my video, click on the like button, the subscribe button, notification bell. Visit my math website, www.mathfullyexplained.com. to find more information about me, my videos, and the content. And that's the content that's on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Bye-bye.